really couldn't have a discussion about how the technology and policy environments were affecting the internet and all of its ramifications without really looking at some use cases and making sure that we're not just thinking of the obvious, but understanding how far the technology and digitization has gone already and is likely to go. So I'm really very, very grateful to Doug Brent for being with us today. He's the Senior Vice President of Technology Innovation at Trimble Corporation, which he joined in 2011. And in that role, he's head of Trimble Technology Strategy. He catalyzes cross-company technology collaboration, very important in a technology company, and he works to enhance Trimble's worldwide engineering and innovation culture. Active projects at Trimble include augmented reality, particularly the Hololens-based initiatives, software replatforming, and autonomy components and solution. It's a company that is really transforming the workplace in agriculture, in engineering and construction, architecture, and other areas. Doug has a 30-plus year of record of management and leadership in high-tech companies in Silicon Valley as a VP of engineering of several startups, as well as a general manager earlier at IBM and a product development at Apple. He also served as chief operating officer at the Internet governance organization ICANN. Everyone here knows ICANN, from 2006 to 2010. And he serves on the advisory board of a number of companies as well as not-for-profits. So he's joined us from Sunnyvale to be with us on this rainy New York day. So please join me in welcoming Doug here today.
Yeah, are we good? Yeah, most audiences wouldn't know that ICANN reference, but that was the one very different role I had in my whole career. Other than that, it's been product development. So I think I should start this by saying, and now for something completely different, because I'm not going to be talking about policy, but really more about, I think, applications of technology that may not be top of mind as the policy people here are thinking about policy, so maybe I can do that. So I guess if I had three objectives for this short presentation, one would be maybe to give you the industrial technology context for thinking about policy, and I think it's a little different than the consumer. The second one would be, I think this stuff is a lot further along than sometimes we think it is. This technology is really quite advanced in terms of deployment. And third, and it's interesting, we touched on this just at the end of the last session, that the affected industries have a huge opportunity for cost savings, efficiency, safety. So as these policy discussions are happening, not to just be thinking about the technology companies, but their customers, who they serve, and what the opportunity is. And I promise you, it's all pictures, so it's not going to be too challenging for lunchtime. So I use this word IoT. It's one of the buzzwords I despise most in the technology industry because I don't know what it means. I think everything is the Internet of Things. I think we've had that for quite some time. Good catch. So I'll just say that this IoT future is already here, and I think I'll give some examples of that. So I think a lot of the discussion, the background thoughts we have in our minds are these kinds of products. So, Google Waymo, autonomous vehicle. I decided not to be all Google here and put a Nest, so I put an Amazon Alexa up there in the left corner, and maybe this nice office collaboration environment at the bottom. I think in a lot of these discussions, we're consumers. We consume this kind of technology, maybe not the autonomous vehicle yet, but we consume it so we know it, and so it's a comfortable place to be. This is really a different world that I'm talking about, and really to have the technology discussion, I think you have to start with the people, not the technology. So one of my favorite pictures here, if you look in the upper left-hand corner, somebody carrying grapes. I didn't carry along, the title of that picture was The Romantic Douro Valley. It's probably 45 degrees centigrade on a 15% grade slope that's very rocky if you've been there before, and somebody's carrying grapes up. They're not having a romantic experience. This is really hard work that's getting harder and harder to find people to do. I was in India in February, and you might get the feeling of that construction environment in the bottom right being India. The largest construction company in India, L&T, $10 billion in revenue, says their number one problem is getting trained labor in India. If you talk to the American Trucking Association, same thing, trained labor. These are hard jobs that have safety concerns in difficult environments. The big problem today is not saving these jobs, it's how do you help these people do the jobs better in a safer way, and frankly, make up manpower shortages that exist globally. So I like that picture of collaboration, that office environment. Probably if we were all collaborating, we'd have these nice office tools, would be sitting around a whiteboard. This is a collaborative environment, probably happening out there as we speak. So the big opportunity in building construction, if you think about the last 30 years of technology in manufacturing, it's been how do you make these worlds highly optimized? This process is very poorly optimized. So today, we could debate around the world the exact numbers, but 20 to 40% of building cost is waste. So if you build $100 million building, it's going to be $20 to $40 million wasted. There's a huge opportunity for making that a better world, and a lot of that has to do with process integration of all the elements of building a building. Someone designed the steel that goes into this building. You know when that steel is going to arrive. What crane should lift that steel up? This is the kind of collaboration environment that, as we're thinking forward for data that we need, I find this even more exciting than the office collaboration. So this Internet of Things, at least in our terminology, what we talk about is connecting digital and physical world. And it's actually a two-way connection. I want to cover both parts of that. But if you look at these pictures, can you identify what's in the upper right-hand corner there? Anybody? It's a farm tractor, combine. And some of that shows 3 LCDs in the combine. It can be 6. You know, agriculture is already a very high-tech operation today. In Europe and North America, more than half of all tractors today, and has been for a while, are already automatically guided. So when we think about autonomy, we think about the Google autonomous vehicle. Really for 5 years, going back 15, but for 5 years, the majority of tractors have been automatically guided. And the reason why that is, by the way, is because the computer can guide the tractor within, let's say, an inch, couple centimeters. And the efficiency of putting down fertilizer, seed, land utilization is enormous for farmers. So that's already happening today. The trucking industry today, primarily again Europe and North America, but growing. We do this in India, for example. Trucks are highly outfitted computing platforms. So you might think about it as something that moves goods, but they're actually incredibly instrumented. Tire pressure, engine monitoring, video cameras pointing in every direction to help that truck behave more efficiently. I won't go through all of these in the interest of time, but if you can sort of see this picture in the lower left, what that is trains running by cameras going about 60 miles an hour, where the camera system is inspecting all aspects of the train wheel to see if it's actually suitable for operation. Again, thinking about the safety of industry and cost, a derailment costs somewhere between $200,000 and $1 million per incident. Inspecting trains is something, at least in Europe, it's a little bit better. In the US, it's done by people walking by train cars and sort of guessing if those wheels are actually working or not. More and more, this connected world is being able to provide this kind of information in real time. And that's true for the water network and irrigation as well. I said I was going to talk about both ways of connecting that information. Most of the things we think about as being participating in this Internet of Things world are not connected to the internet. At home, it's very easy for me to hook up a thermostat or irrigation system. I have my Wi-Fi network. A lot of the industrial world is where there is no internet. If I'm building a road out at the end of the road, railroad line, there may not be any internet out there. And there's a lot of old technology that will live for decades that's already deployed. So one thing I can do is visually look at a valve or look at a gauge and detect a reading on a gauge. That's one way to connect it. I want to show an example, and these happen to be Hololens examples. I just met someone here from Microsoft. Can you go ahead and play that video, please? Whoops. Can you go? Yeah, thank you. So this is actually using HoloLens, that's what it looks like, by the way, in a partnership with the University of Cambridge, in a bunch of construction-related activities. That first one where she was dragging the rebar cage is actually using HoloLens for validating rebar design in nuclear power plant construction. It could be looking at a building site to try to understand as-is versus building design. For visualization of 3D models, and in fact, this idea of architects collaborating around 3D models has been a huge driver of innovation already. Still have to work on the look. I think that Geordi Star Trek look is still not perfect. And then this just gives you an idea that you can make these real-world environments mix. Just a quick primer. Everybody knows about virtual reality, Oculus, Samsung phones. Basically, you're putting two TV screens over your eyes and you're seeing a virtual world around you. The difference with this technology is that you can still see the real world. I could see that rebar cage, the iron pieces that make the core of the structure of the concrete, but I can overlay on that, see the 3D model. So it's this idea of augmented reality is completing that physical to digital, digital to physical necessary transformation. Not even a laugh. So the bulldozer says, I'm a 3D printer too. And in fact, that's the way it actually works in the modern world. Not for all operations, but let's say for doing a airport runway or a lot of road work, the 3D model is sent to the construction machine. The construction machine then basically knows what the grade should be, where the blade should be, and digs a level platform, or will lay just the right amount of asphalt or concrete. And I think if we could get out of using this word autonomy and more automation, autonomy feels valuable to us because frankly, at least I don't want to drive. I want to be driven and I can do something interesting. But I think the values of automation are going to be driven much more application specific. In mining today, where autonomy is very accepted, it's about safety. It's not, the driver is a very small cost of the total cost. In agriculture, they really don't want to replace the farmer. They want to make the farmer more efficient. So if you could just play one of these videos, the one in the lower right-hand corner, I think this will give you a better idea of what I mean by automation. So this tractor's been given a job, cut out a particular irrigation pattern, a water pattern, so the water will go in the right direction. It's a big job. And by sending that work to the tractor, letting it do it automatically, you get away from boredom, but it really has nothing to do with replacing the driver. So everything I've shown you so far is real. These are real products that have been sold for 10, 15 years. Of course, like everything else, they get better and better and do more and more. I'm going to talk a little bit about the future here. So the purpose, ultimately, the big win out of autonomy, out of automation, is that I can orchestrate vehicles together. In the consumer car sense, we talk about traffic improvements as being a big benefit. But you can see here that these industrial environments involve a lot of coordination, and being able to coordinate those things together is of the essence. And I want to just show you one sort of scary video. If you could show the one in the upper right-hand corner, please. This is the way. I just want to point out that truck in the back, and then I'll comment. So that's really the way sugarcane harvesting is done, and those machines are gigantic, and unfortunately people sleep in the sugarcane fields, and human harm comes not too infrequently. It's run 24/7 when when it's night outside, they just put up some lights, they keep farming. For that kind of world, what's most important is when they talk about autonomy or automation, there was that truck following the harvester. They want coordination. in a lot of these things, you hear about truck trains that have been prototyped. It's coordinating all of the vehicles to be at the right place at the right time to deliver highest productivity. So I promised all pictures, just one slide with words at the end. I'm not trying to, in a room full of policy people, I'm sure not trying to offer any policy, but I will say a couple of things I think make sense from a industrial technology company point of view. That this idea of improved industrial collaboration, mental model, think about what's happened in manufacturing over the last 30 years, really ultimately is probably a trillions of dollars opportunity. Certainly improved agriculture, but building and construction and road construction and trucking, those three in the US alone are about a $3 trillion industry. If you could make that 20% better, that's a huge impact on the economy, and I think should be front of mind when considering the internet policy concerns. I do think it's funny, I wish Eric Schmidt was here, because when he was at Novell, every year was the year of the land from 1980 to 1989. But it did finally happen. You know, in 1989 or 1988, there really was this tipping point of broad adoption of LANs, and now we sort of, local networks, and we can't imagine, or I can't imagine living without one. So I think that this IoT thing has been around for a long time. By the way, we were talking about AI earlier. AI has been around for an even longer time. But it does get to this point where the technologies work well enough that adoption seems to happen overnight. And I think we really are at that point with IoT adoption. I think it'll happen in a massive way in these industrial markets because the efficiency gains are so huge. This idea of automation and orchestration, I think, is very important because we all have this consumer mental model of, I have my cell phone talks to some cloud service, and I get an answer back from the cloud service on my cell phone. That works great for a lot of consumer things. I'm not going to rely, because of latency and design reasons, I'm not going to rely on all cloud processing when I'm running a tractor in a farm field or I'm running a big excavator down a road. Some of that has to happen locally. So the architecture is actually how you design the computing solution depends on the problem you're trying to solve. And again, from a policy point of view, I just wouldn't assume it's always a big central processing cloud in the sky. And for data movement and processing movement, it's going to have to be pretty flexible to be where the problem actually is. And I think, certainly, Trimble has no view on internet policy. I don't think you could find anyone there who could talk about internet policy. But I think that there's a fundamental assumption that we can deliver better solutions to the extent there's an open internet that operates by transparent rules. And of course, as a company, we'll adapt to whatever the environment is. But I will say, as the rule environment gets more complex, just to pick a really outrageously end case example, I know in the military they talk about changes to their software systems on the order of a few lines of code per week. That the amount of regulation is such that they're able to attain a few lines of code change per week. That may be a great thing for a cruise missile. But I think that when you talk about the impact on innovation, one of the things to consider is how fast can we go to serve the needs of these trillion-dollar industries, that have a big opportunity for impact. So I hope that met the case for, now for something totally different, and I enjoyed it. Thank you.